Alrighty, kiddos, this is Mrs. Williams. I hope you're doing okay. I certainly have missed you, missed seeing your faces and hearing your voices and everything. It's been fun for me just doing a little bit of chatting on Teams that we've done so far. It definitely has put me in a better mood. So this is our first little review session, so I just wanted to go over how to solve systems by graphing again. We're going to go where they start out in slope-intercept form and then get just gradually a little bit more difficult where they are in standard form or some other form. Remember, when you're solving a system of equations, you can have, all right, here we go with a pen that we know I always have difficulty with. Hold on. All right, ink. Okay, almost there, guys. Okay, all right, so you can have one solution. Okay, you can have 0 solutions and you can have infinite solutions. Okay, remember infinite solutions, that's when the slopes are the same and the y-intercepts are the same. So the m's and the b's are the same. Okay, now when there are no solutions, that means their slopes are the same, but they never intersect. So they're parallel, so their y-intercepts are different. And then when there's just one solution, okay, so both the slope and the y-intercept are going to be different, okay? So first thing you should always do is get them into slope-intercept form, remember. So if we look at number 1 here, you can see that it's already in slope-intercept form. So what I'm going to do is just graph. So I always start, I'm going to blow this up a little bit. I'm going to graph this guy in red. And remember, there's no shading with an equation. So the only solutions are actually what's on that solid line when you graph it. Okay, so I'm going to start with a y-intercept, which we know is -3, so I'm going to graph that, and this graph is going to be perfect. See, my y-intercept already went away. So, guys, what lights up a soccer stadium? A soccer match. Oh my goodness. Okay, you guys have missed me. All right. So I plotted the y-intercept there, and then remember the slope is 1/2. So it's always the vertical change over the horizontal change. So that means it's a +1 over a +2, which means up 1 to the right 2. So from the y-intercept, I'm going to go up 1 to the right 2, and then I'm going to draw my perfectly straight line through them. Okay, and remember there's no shading. The only solutions to an equation are the points that are on that line. All right, and so then let's do the other one. Let's do it in a different color just because that's fun. All right, so now I'm going to graph this guy in blue, again starting with the y-intercept of -1, the b is -1. Now this one's a little different in that the slope is negative, so we know that it's going to be going down. Okay, when the slope is negative, we know it's going to be going down. So again, vertical change over horizontal change, so it's going to be going down 1 to the right 2. All right, so from -1, I'm going down 1 to the right 2. So you can see, you can see, whoa, guys, you guys are like right back in the classroom, aren't you? All right, so erase the whole thing. Okay, so y-intercept -1. Oh my golly gee. Y-intercept -1, slope -1/2, down 1 to the right 2, and then I'm going to graph that line. And when you guys do this, especially when it's on the computer, it's nice and straight for you. The solution here would be the point 2, -2, because that's where they overlap. Okay, so always get them in slope-intercept form first. We have another one here, very similar to what we just did. I don't think that you guys need that. So I'm going to go ahead and come on down here where they're a little bit more difficult. Okay. All right. Do you want me to do 3 or 4? Okay, a majority of you said 3. So we'll go ahead and do number 3. All right. So put them in slope-intercept form first. So let's do this one, the one that's on top first. So of course we have to get rid of the 4x on either side. So when we do that, you're going to end up with -y equals -4x minus 1, because I subtracted that on both sides. Okay, now I'm almost there, except that I have that negative, rascal negative in front of the y, and I want it to be not a negative y, but just a positive y. So I have to divide every single term by -1. Okay, when I do that, I get y is equal to -4 divided by 1 is 4x, and then -1 divided by -1 is a +1. Okay, so that's my first equation. Y equals 4x plus 1. So we'll go ahead and graph that again, starting with the y-intercept of 1. And then the slope is 4. Oh, my y-intercept disappeared again. All right, so the slope is 4. So that means up 4 to the right 1. So from the y-intercept that disappeared again, I'm going to go up 4 to the right 1. So those are my 2 points. Stay! All right, and then I'm going to draw my perfectly straight line through them. All right, now if we look at the next equation, the system has the 2 again. So this one is x subtract y is equal to 2. Okay, again, we have to get that y by himself, so I'm going to subtract the x on both sides, which leads me to -y equals -x plus 2. Miley, I need your stylus, my dear. All right, hold on. There we go. I think that's right. Good. And then we just have to divide everything just like the other equation by -1. So now we have y equals a -1x over -1 is positive, so just x, and then 2 divided by -1 is -2. So that's my other equation. So I'm going to plot that. Again, the y-intercept is -2. And I have a short-term memory, so I've forgotten what the slope is. It's 1, up 1 to the right 1. All right, and so I'm thinking that the solution is probably -2, -3, and you can plug it in and make sure. But I think, yeah, that would be right. Okay, so this would be my solution right there where they intersect. Okay, again, the intersection is the solution. And remember, what a solution is just a point for equations, a point where if you were to plug in the x and the y to both of those equations, it would make a true statement. Okay, remember, that's all a solution is. So what I'm going to do now is I'm going to save this, put it in Teams, because that's where you're going to be looking at it, and then I'm going to assign 5 solving by graphing problems on Delta Math. All right, thanks, kiddos.